buffer. pH of acidic buffer. Now see, this weak acid is going to dissociate like this. Okay. Now Ka, that is the dissociation or ionization constant, it is written like this. Okay. So from here you get okay, fine. Okay. So if I take a log on both the sides, I'll get log of H plus log of Ka plus log of acetic acid upon acetate ion. Okay. Now take a negative sign on both the sides, you'll get minus log of H plus minus log of Ka, and here instead of putting minus over here, I am inverting it. So this will be log of CH3CO minus by CH3COOH. Okay. So minus log H plus is pH, minus log Ka is pKa plus, and this is log, see what is this, CH3CO minus, and what is this? This CH3CO minus ion is nothing but the base which is present in the form of salt. So the acetate ion, CH3CO minus ion concentration will be the concentration of the salt, right? So this will be log concentration of the salt, and this is the concentration of acid. This is the expression of pH of an acidic buffer. Okay, great. Whew. Now the question arises, why the pH does not change on dilution? Okay, let me just elaborate this particular expression. Now this expression can be written as pH is equal to pKa plus log number of moles of salt upon volume of solution upon number of moles of acid by volume of solution. I hope all of you will agree with this part, because this is how concentration is written. Agreed? Now, my dear friends, let us see over here. So these are the moles of acid and salt. Let us suppose that the volume of the solution is 1 liter. Okay, how much is it? 1 liter. Now if I increase it by any volume, suppose if I add some water, what will happen? The volume of the whole solution will be increased. So over here the volume will be 1 plus x, over here also the volume will become 1 plus x, because it is the volume of the solution. If you are adding some water, it is the volume of the solution which is changing, right? So if you increase the volume of the solution, my dear friends, what is going to happen? The change will be there on the denominator side as well as on the numerator side. Okay, and in any case this is going to get cancelled out. Keep on adding water, hardly matters, because the volume on the numerator and the denominator side is going to get cancelled. So there is no effect on the ratio, because number of moles remains same. So the pH remains same. So that is the reason why there is no effect of dilution on the pH value of buffer solution. Tell me, is this part understood? Any difficulty, mushkalti, pareshanality to anybody? Understood this point? Clear? Okay? Okay, great. Now the second thing is, how come we can drink that Golgappa water? How come the blood basically is resisting the change in the pH? So herein we have to talk about the buffering action. Now we have to talk about the buffering action. So you see, so this is the weak acid plus this is the strong base. This forms AB plus water plus H2. Now you have to understand this part, that because this is a strong base, this is a weak acid, the salt will be a basic salt. Salt will be a basic salt. Okay, please remember. So the concentration of acid is taken to be A, the concentration of salt is to be taken as S. Okay, now case 1. If I am adding acid to the mixture, say X mole of acid is added. What happens if X mole of acid is added? Now what happens? See, the acid has got two compounds. One is the acid, one is the base. But obvious, acid will combine with what? Mr. Sir, acid will combine with base. So this acid will combine with this salt. So if the acid is reacting with the salt, the amount of salt remaining will be S minus X, and the amount of acid formed will be A plus X. Are you getting my point or not? Say for example, I am doing it over here. For example, suppose if I add one HCl over here, so CH3CONa will react with HCl. Say this is 5, there is one HCl. It will give you CH3COOH plus NaCl. So this will be 5 minus 1 is equal to 4. This is 1 minus 1 is equal to 0, and this is 1. Already you have got 95, so 1 plus 95. Agreed? Agreed or not? So by adding a small amount of HCl, this salt is taking care of this acid. This is what is called as the buffering action of acid. Understood? Okay, fine. So salt minus X, acid plus X. Salt minus X, acid plus X. Now what will be the pH? New pH? This will be pKa plus log S minus X, A plus X. So if you see that acid which you are actually adding into the buffer, it is being neutralized by this basic salt. So this basic salt behaves as a buffer against the incoming acid, and that is why you see the change on the pH will be very, very less, very, very minimal. Why? You see, first of all, it is the X is not adding directly to the pH of the solution. It is not adding directly. It is first reacting with the salt, then some acid is formed. So what is the change over here? The change will be over here in terms of this ratio, and as you can see that the ratio will decrease. The ratio is going to decrease, but very slightly. If the ratio is going to decrease, the value of pH will be decreasing. Okay, fine. So pH decreases slightly. Agreed? Okay. What if, now let's talk about case 2, X mole of base is added. If you are adding the base, it will combine with the acid. So this will be A minus X. Some more amount of salt will be formed, so it will be S plus X. So now the pH will be pKa plus log of S plus X upon A minus X. As you can see that the ratio is slightly increasing, so pH increases slightly. Got the point? Understood the buffering action of buffer?